Look at this number line. Nothing unusual, just numbers spread evenly across space. Now, let's perform one simple operation. Multiply every number by 2. Watch carefully. The entire number line stretches. Every point moves from 0, 1 becomes 2, 2 becomes 4, and 3 becomes 6. Every distance double. We've seen this before. Multiplication doesn't simply change numbers, it stretches space itself. Now, let's do the exact same thing again. Nothing changes about the rule. We're still multiplying by 2. Yet, somehow, the movement is larger. The point that actually started at 1 has reached 4, and the point that actually started at 4 has reached 16. Do it again, then again. The rule never changes. The operation never changes. We are repeating exactly the same transformation. So, why does the same result seem to grow faster every time? Where is this extra growth coming from? It isn't hidden inside the 2 number. It is not hidden inside multiplication. It is hidden somewhere else, somewhere much more subtle. Because every new stretch is acting on a space that has already been stretched, and that tiny idea changes everything. Let's slow the animation down. Let's just focus on one point, the number 1. Multiply by 2. The point moves here. Multiply by 2 again, it moves again and again. Now imagine that every after stretch, the number line stretches back to its original size. Every multiplication will look identical. The point will always travel the same distance. Nothing surprising would happen, but that is not what multiplication does. The number line never resets. Each transformation permanently changes the geometry of space. Every gap becomes larger. Every distance expands. So when the next multiplication begins, it isn't acting on yesterday's number line. It's acting on a completely new one, a larger one. So do you notice what this means? The rule hasn't become stronger and the number 2 hasn't changed and the mathematics hasn't changed. Only the word being transformed has changed. So let's make this stretch visible. Final stretch. First stretch, second stretch, third stretch. Instead of watching the numbers, watch the space between them. Each gap doubles. Then those larger gaps doubles again. Then those even larger gaps doubles again. The distances themselves are growing. Now something remarkable happens. The stretch begins to build one another. Each new transformation inherits every previous transformation. Nothing is lost and nothing is reset. Every new stretch carries the entire history of every stretch before it. That is why the growth begins to feel explosive, not because the rule changed, but because the stage on which the rule acts keeps getting larger. And once a transformation starts building upon itself, we've entered an entirely different kind of mathematics. Up to now, we've been repeating the same stretch again and again and again. But mathematicians noticed something interesting. Instead of drawing every stretch one at a time, what if we simply counted them? Let's start with the number 1. One stretch, it becomes 2. And the second stretch, it becomes 4. The third stretch, it becomes 8. And the fourth stretch, 16. Notice what is changing. Not the rule. The rule has always been the same. Multiply by 2. What is changing is the number of times the rule is applied. Instead of writing every steps, mathematicians give us a shorthand. One stretch becomes 2 raised to power 1, and 2 stretches becomes 2 raised to power 2, and 3 stretches becomes 2 raised to power 3, 4 stretches becomes 2 raised to power 4. So that tiny number floating above the 2 isn't telling us how big the answer is. It keeps counting. It is counting how many complete transformations have happened. This changes the way we think about exponents. The exponent isn't a number that makes things grow faster. It is a counter, a record of history, and every time it increases by 1, another complete stretch is added every time that came before it. Nothing is erased, nothing starts over. Each new transformation inherits every previous transformation. So let's make that visible. Instead of watching the point, watch the entire number line. One stretch, the whole line expands. The second stretch, the already expanded line stretches again. A third, a fourth, the exponent quietly increases. 1, 2, 3, 4, while the geometry beneath it keeps transforming. Suddenly, that tiny superscript doesn't look so small anymore. It is counting something enormously powerful. Not numbers, not transformations. And once you realize that, a much stranger question appears. If the exponent only increased by 1 each time, why does the answer seem to explode? Where does that explosion actually come from? Let's compare two words. On the left, addition. On the right, exponent. Each step on the left word added exactly 1. 1, 2, 3, 4, 5. Each step covered the same distance. Every change is predictable. Now, look at the right. 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. The exponent also increased by exactly 1. The same time step, again and again and again. But the answer didn't behave the same way. 2, 4, 8, 16, 32. The exponent moved linearly. The value doesn't. Why? Because the exponent isn't changing the answer directly. It is changing how many transformations has accumulated. Imagine stacking transparent sheets of glass. Each sheet magnifies everything beneath it. The first sheet doubles the size and place another identical sheet on the top. It doesn't magnify the original picture. It magnifies a picture that had already been magnified. Add another and another. Each layer receives everything the previous layer already created. That is exactly what is happening here. Each new stretch acts on a space that has already been stretched. The transformation itself never becomes stronger, but it affects grow larger because every previous transformation is still there. The growth isn't coming from the present, it is coming from the entire history of the process. This is the hidden amplifier. The past never disappears. Every stretch carries it forward. Every exponent remembers every transformation before it, and that is why exponential growth feels so deceptive. The rule looks simple, the changes look small, but beneath the surface, every step is carrying the weight of every step before it. And by the time our eyes notice what is happening, the explosion had already begun. So far, we've watched the transformation repeat again and again and again. But here is something strange. If I ask you to guess where this point will be after 20 stretches, could you do it? Most of us can't. Not because the mathematics is difficult, but because our intuition was built for a completely different world. Let's see why. Start with a single point. Stretch the number line, the point moves a little. Stretch it again, it moves again, farther still. At first, the movement feels almost disappointing. Nothing dramatical happens. The point drifts away slowly, predictably. If we stop here, you might even wonder, is this really what all the excitement was about? But don't stop. Keep applying the same transformation again and again and again. Now, something changes. The point begins to cover enormous distances. Not because the rule changed, but because every new stretch begins from a much larger space than the one before. The early stretches hide what the later stretches reveal, and that is exactly why exponential growth surprises us. We judge the future using the speed of the beginning, but exponential growth doesn't have one speed. It creates a new speed every single step. The beginning whispers, the ending shout, and by the time our intuition realizes what is happening, the explosion has already begun. At this point, it might actually seem like exponents are just another trick numbers can play, but they aren't. This idea reaches far more arithmetic. Let's leave the number line behind. Instead, look at this grid. Every square is exactly the same size. Now, stretch the grid by 2. Every square becomes larger. Every gap expands. Every intersection moves farther apart. Nothing surprising yet. Now, stretch the already stretched grid. Again, again, again. Watch what happens. The grid doesn't even simply become bigger. The entire geometry changes. Distance that once seemed close are now impossibly far apart. Tiny differences becomes enormous separation. The world itself begins to unfold faster and faster. And this is the same transformation we've been performing since the beginning. Only now we can finally see it. Exponents aren't just making numbers large. They were about repeatedly transforming space. Every transformation changes the geometry, and the next transformation inherits that new geometry. That is why exponential growth appears everywhere. Not because nature likes big numbers, but because nature is full of processes that repeatedly build on themselves. One event creates another, which creates another, which creates another. The mathematics is always the same. Transformation build upon transformations. So let's go back to the question we asked at the beginning. Why do exponents explode so fast? At first, it feels like the answer should be hidden inside the number. But maybe the number 2 is somehow special. Maybe multiplication is secretly becoming stronger. Maybe something mysterious happens after enough steps. But none of those were true. The transformation never changes. Every step follows exactly the same rule. Multiply, stretch, and repeat. The real secret isn't transformation. It is the word that transformation acts upon. Every stretch creates a larger space. The next stretch doesn't begin where the last one started. It begins where the last one ended. Every transformation inherits the entire history of every transformation before it. Nothing is reset, nothing is forgotten. The past is carried into the future, again and again and again. That's why exponential growth doesn't simply add change. It builds change on top of change. The more it grows, the more the growth it creates. And that is why something as small as increasing an exponent by 1 can completely transform the result. So maybe exponent doesn't really explode. They simply reveal what happens when transformations are allowed to build upon themselves forever. And once you start seeing exponent this way, they stop feeling like a formula and start feeling like a new way to look at change itself. But this isn't final mystery. We've been using the number 2 this entire time. Why 2? Could we have used 3, 5, 10? As it turned out, there is one very strange number approximately that appears whenever growth becomes perfectly continuous. It shows up in finance, population growth, probability, physics, engineering, and even quantum mechanics. Why does nature keep choosing this one number? We'll beat that intuition next time. And if you like this, make sure you like and subscribe for more. And I hope to see you next time.